Hello. 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 Yeah, very good afternoon. I think everyone in happy mode, right? Please raise your hands. How many cleared? I think almost all. So you are toppers in the Kakinada University. Yes, is correct. The no affiliated college will get the 90% or 99% pass percentage. Only the 50 to 60 or 40 to 50 will be pass percentage. But your college, most of the students are cleared. Okay. Hearty congratulations to you. Namma? Okay. See, the 8255, hello. The 8255 is used to connect the external devices. That means the mediator between the processor and the external devices. Now, like similar 255 micro 8255 PPI, the programmable peripheral interface device, the some other interfacing device also there, the specific purpose, but the 255 purpose, the general purpose PPI. So you can connect any device to PPI and PPI to microprocessor. But similar to 8255, some other specific device are there. Those device memory inter 80. What is the capacity of 8086? Anyone can answer? The memory capacity of 8086 microprocessor. 120? 0. The memory capacity of the 8086 is 0. There is no memory with 8086. But the 8086 can access 1 MB of memory from the external device. Not more than 1 MB. That can access the 1 MB. That means the 20 address lines there. Using the 20 address lines, the 8086 can access the 1 MB of memory from external memory devices. Right? The external memory devices. So now, how we are interfacing the memory to the 8051, 8086 microprocessor, we'll discuss now. Here, coming to the memory again, the two types. The program memory and data memory. You already discussed the code segment, data segment, stack segment, and extra segment in 8086 microprocessors. Right? Now, so how we can access the data memory and program memory we'll discuss. Now you can see this, the memory, that is the store programs and data. The store programs and data. The program memory is the different and the data memory is the different. The data values can be stored in the data memory and the program code. If you are writing the any application, that application programs can be stored in. That means your programs can be stored in the code memory space. That is okay. That is the program memory and data memory. Next, primary memory means the program using address lines, and secondary memory means secondary memory like CD-ROMs, external hard disks. So, and here see the memory divided into three: the processor memory, primary memory or main memory, and secondary memory. The secondary memory. So in primary memory means the all registers of 8086 microprocessor. That is the accumulator, the base register BX, CX, DX, and all other core segment registers and all this. So here the registers inside a microcomputer, there is a microprocessor, and store data results in the temporarily. And here this primary memory, depending on the memory type, the primary memory is the cost, more cost. And coming to this, the main memory, that is the storage area. I already given the memory hierarchy. What is the memory hierarchy in the computer? You study the computer architecture subject. Computer architecture. So in that computer architecture, the memory levels are cache memory. The cache memory means the memory with the processor. The memory, the processor is called the cache memory, and outside the processor memory is called the primary memory, and external memory is called some like CD-ROMs, DVDs, and separate external hard disk, SDD or SDD, the solid state device or the hard disk drive. That is the external hard disk. So depending on the level of the memory, the cost will increase. If the memory with the processor will the more cost, and the primary is the somewhat less, and external memory is a very, very less cost. Okay, that is the memory hierarchy. Now, this processor memory is the very cost, and this one is the primary memory, just outside the processor. That is called the main memory. That memory is called, for example, the main memory means this laptop is there. The laptop is having the 500 disk hard disks. That memory is called primary memory. Okay. And if any external pen drive or any external hard disk we are connecting, that is called the external memory. So that external memory is, that is called the secondary memory. That cost is less. Now we are connecting the already primary processor, or the primary processor memory is the with respect to registers, and the primary memory is we are connecting to the processor. This. So how we are connecting the processor and how we are accessing the data. Microprocessor is having the data lines as well as address lines. How many address lines with 8086? The 20 address line, that is a 0 to 19. The 0 to 19 means 20 address lines, and the data lines are D0 to 7, D7, and D50, D8 to D15. Miku, for example, this is the memory device. Indulo device మీరు layers ఎలా పెడతారు? For example, you can assume the your almara. How you are placing the cloths in that almara? One by one. So we are giving the addressing. Address ante bottom one, middle one, and fourth one, fifth one, like that. So here also same, we are assigning the memory. The each memory location can occupy the only 1 byte of information. Ante meeku 20 address lines unna gani aa naming ivvadaniki 20 address lines vadutunnam, but the each location can stores only the 1 byte of data. Okay, so that data can be accessed using the D0 to D7 and D8 to D15. This is the address bus, and this one is the data bus. The data bus is the D0 to D15, and address bus is the A0 to A18. And here also chip selector. This is the memory device, and this one also memory device. To enable that memory device, we are using the chip selector pin. That is the CS bar. And here also CS bar. You can enable this CS bar pins. Now, the memory integrated circuits are byte oriented. Byte oriented means the each location can store the 1 byte of information. 1 byte here, the second byte, third byte, fourth byte, like that. The each location can store only 1 byte of information. That's why we are calling as the byte oriented. And we are accessing the 16-bit data. Why the 16-bit data? Because our code segment registers are in 16-bit in size. So that's why we can access the memory in terms of 16 bits. And here, A0, bank 0. Bank 0 means even address and odd address. How we can access the even address and odd? By enabling the A0 pin, we can access the even address data. And by enabling this BHE pin, we can access the odd address data. Odd data. 00 location is the even address data. 01 location is the odd address data. 02 even address. 03 odd address. So like that, we are placing here. ఇది ఒకవేళ 16 byte information ఉంటే, in that 16 bit, that is the first 8 bits and second 8 bits. This is called the even address data, and this one is odd address data. Okay. See, A0 and A1. Which one is enabling here? A0. So even address data D0 to D7. Next, whenever this BH is enabling, why it is enabling? A0 is equal to 0, even addressed bank, even address data. BHE bar is equal to 0, that is the odd address data. ఇక్కడ A0 equal to 1 ఉంటే, that is the disabling. BHE bar is equal to 1 ఉంటే, that is the disabling memory. Okay, you can see here 10 means here the A0 is high. So therefore, the even address data we are accessing. Read, write, byte and even address data. Even address. And here BH is equal to 0 here. And this one is the disabling. BH is the enabling. So therefore, the read write operation using odd address data. Okay. Next, here both are 00. That means we are accessing the total even address data as well as the odd address data. That is the using the D0 to D15 pins. Using the data 16-bit data bus, we are accessing this complete data. That is the read operation or write operation using the complete address. That is D0 to D15, even and odd address. Next, if 01, that is again the D0 to D15 first rotation, first operation byte from the odd bank is transferred here because the BH is enabled. So odd data can be transferred, and here A0 is equal to 0 means that is the even bank data is transferred first. So that is how we are accessing the data. That is the lower byte as well as the higher byte. That is the even byte and odd byte. Next, total memory. The EPROM is the external memory, and read-only memory with the random access memory. That is the processor memory is the total available memory of the processor is. We can connect EPROM plus RAM. Next, allot equal address space in the odd and even bank for both EPROM and RAM. So that means you can take the same size of even bank and odd bank, the both banks for the same size for the random access as well as the permanent memory, read-only memory. EPROM for permanent. Already we have discussed the read-only memory. That is a permanent memory, and this one is random access memory is the temporary and read-write memory. Next, to select that memory, we need to enable this chip select CS pin. Compulsory, we need to enable this. Then only, see, with respect to microprocessor, all external devices are having one pin compulsory, that is the chip select pin. That is the chip select pin. If you are enabling this chip select pin, then only that device can be recognized by the processor. If the chip select pin is not enabled, the device is not recognized by the processor. Okay. So all the external device, the 8255, 82 and memory interfacing device. Next, a few more interfacing devices are there, that all devices are having the chip select pin. If it is enabled, then only the chip. Okay.
అవును. Battery same. Battery same. నాకు పెట్టేసేటప్పుడు తర్వాత పనిచేసి అయిపోయింది. వచ్చేయాలి. హ్యాండ్ బ్యాగ్ క్లాస్ నాకు అలా చేస్తాను. అరే కింద ఉన్న వచ్చేసారు ఒకసారి కృష్ణ దగ్గరగా ఉంటుంది కాబట్టి
Hello. Oh, hello. 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 Hand mic. వినట్టుంది. Hello. Hello. Facing of SRAM and EPROM. EPROM means the permanent memory. The SRAM stands for the static random access memory. Okay. So now the interconnection, the circuit diagram for this is if the data bus and address bus. Address means where the data is present. The location indicates the address and data, the which carrying the data, that means the operands required for our applications is a data bus. So the both the static RAM as well as the EPROM both are having address bus and as well as the data bus. So now this address and data buses we are connecting to the our microprocessor. The microprocessor 8086. So the address bus and data bus. The data bus is the 16 bits and address bus is also 16 bit. But the 20 address lines are there, but we can connect only the 16 bits, or you can use the total 20 bits, 20 address lines also. Next. So in 20 number of address lines are 20, that is the A0 to A19. You already seen in the 8086 microprocessor address lines. So we are having total 20 address lines. Using the 20 address lines, the number of the locations, the different locations are the 2 to the power 20. 2 to the power 20. So the 2 to the power 20, you can take the calculate in your calculators. The 2 to the power 20 value is the 1 lakh 10 lakh 48,576. This can be also written as 1 MB, 1 megabyte. The 10 lakh 48,576 also called 1 MB of memory. So that is the 1024 kilobytes or 1 MB. Next, in hexadecimal is not required. So the address range is, the total address lines are 20. In terms of the hexadecimal, that is 00002 F. That means in hexadecimal, the each digit occupies the 4 bits. So the each digit 4 bits, 4 plus 4 plus 4 plus 4. Total 20 address lines. Next. So in the first slide, we said the even address bank and odd address bank. So how we can access the even address and odd address? Now you can see here, this is the total memory 00002 FFH. Now this memory can be categorized into even address memory and odd address. Even address, odd address. So now we are separating this. The even address 512 KB, 512 plus 512 total 1 MB. 1024 kilobytes. The 1024 is equal to 1024 kilobytes is equal to 1 MB. So this is the odd address bank and this one is even address bank. So from this even address and odd address, we can access at a time the 16-bit data. 16-bit data. Are you understanding? The 16-bit data ante oka memory location lo only 1 byte we can store. Oka location lo 1 byte. But 16-bit ela vastundi? 1 byte from 00 and second byte from 001. So the first lower byte from the given address bank and higher byte from odd address bank. So ikkada oka byte, akkada oka byte. So then you can access the 16-bit of data using the D0 to D15 data lines. The 8086 microprocessor is having 16 data lines. That 16 data lines can be denoted as D0 to D15. So the D0 to D7 can be accessing the lower data from the even address bank and higher data from higher address. Okay. Both are same for the random access memory as well as the EPROM, E square PROM or the read-only memory. This is not required. And we'll discuss now this interfacing devices. That is a program read-only memory, DMA controller, program interrupt controller, and programmable peripheral. This one already we studied. Now we'll discuss the 8279, the program read-only memory, and 8257 DMA controller, and 8259 programmable interrupt controller. We are having 8227 is not in our syllabus. We are having 8257, 8259, and one more controller 8251. Not 8051, 8251. So the 8255 is the programmable interface device, PPI. 8259 is the programmable interrupt controller, and 8257 is DMA controller. What is the DMA controller? We'll understand. Next, other one is 8251 serial interface. In case of the serial communication, we can access this. Okay. I will explain the one each purpose. Using this 8255, we can connect the any external device to microprocessor 8086 using this 8255. This is the one interfacing device. The second interfacing device is the program interrupt controller. What is the purpose of the program interrupt controller? ఒక బస్సు ఒకటి సిస్టమ్ యాడ్ చేస్తే యూజ్ చేస్తే ఆ అడ్రస్ బస్ ఆ డేటా బస్ని ఇంకో డివైస్కి అలొకేట్ చేయాలా అంటే ఏంటి ఇంటరప్ట్ జనరేట్ చేయాలా దాన్ని డిస్టర్బ్ చేయాలి డిస్టర్బ్ చేసి అరే బై సమ్ ఎక్స్ డివైస్ ఈజ్ రిక్వైర్డ్ ద అడ్రస్ బస్ ఆర్ డేటా బస్ ప్లీజ్ రిలీజ్ దట్ అడ్రస్ ఆర్ డేటా బస్ టు హిమ్ like that. So we need to generate the interrupts by using this interrupt controller. Inbuilt this 8259 is having the 8 interrupts, but by programming additionally it will control the 64 interrupts. We will discuss later this 64 interrupts of 8259 or inbuilt 8 interrupts of this 8259 microcontroller. Next, DMA controller. The DMA controller, DMA stands for direct memory access. Direct memory access. For example, this is the one input output device, and this is the memory device. These both are connected to processor. You can consider me as a processor. So the input device is connected to the processor, and this memory device also connected to the processor. Now, by using this DMA, ఇప్పుడు ఈ రెండు కాంటాక్ట్స్ పాసిబుల్ అవుతుందా? Listen carefully. See here. Now this bottle you can treat as a processor. This is the one memory device, and this is the one input output device. Now the data transfer between this memory device and this input device using this microprocessor only. Okay, but so for every memory and every data transfer or the any task completion through the microprocessor only. Now this పక్కన పెట్టి ఈ రెండు యాక్సెస్ అవుతూ ఛాన్స్ ఉందా? There is no chance. But if you are using this DMA controller 8257 or 8237, both are same. 8257 or 8237 DMA controller, the direct once this processor can establishing the connection between ఇది కావాలి, ఇది లేకుండా ఉండదు processor. So now the processor is establishing the connection between the input output device as well as the memory device. Now this after establishing the connection, this both devices can transfer the exchanging the data between this device and this device without interrupting the processor. That is the advantage of, that is the use of 808257 DMA controller. Once the connections are established, the processor will not side, then the both devices can transfer the data between the input and as well as the memory devices. That is the processor bypassing. Okay, you can see 8259 is the programmable interrupt controller, 8257 is the DMA controller, and 8255 is the PPI, the programmable interface device, and write down interfacing devices. Write down everyone. 8255, I will dictate, you can write. The programmable peripheral interface device. 8255 programmable peripheral interface device in bracket PPI. Next one, 8257 IC number 8257 IC number 8257 DMA controller. DMA in bracket direct memory access. DMA stands for direct memory access. DMA controller. The third one, 8259 the programmable interrupt controller in bracket PIC, PIC. 8259 the programmable interface, programmable interrupt controller in bracket PIC. 8259 the programmable interrupt controller. The next one, 8251 universal synchronous 8251 IC number 8251 universal synchronous asynchronous universal synchronous asynchronous receive transmit. Universal synchronous asynchronous receive transmit in bracket USART. Abbreviation చెప్పడైనా capital letters లో రాయాలి. Don't write in small case letters in any subject. Okay, USART. So these are the subjects we are going to These are the ICs or interfacing devices we are going to study. Now, for example, listen, I want to connect the stepper motor to 8086 microprocessor. How to connect? The which interfacing device is required to connect stepper motor to 8086 microprocessor? ఏది వాడాలి? 8251, 8255, 8259, 8257. 8255 is required. అది జనరల్ పర్పస్ PPI ఇంటర్ఫేసింగ్ డివైస్. స్పెషల్ ఫంక్షన్ అంటే ఏంటి ఇక్కడ? ఇంటరప్ట్ జనరేట్ చేయాలంటే స్పెషల్ ఫంక్షన్ ఇంటరప్ట్ జనరేషన్, దట్ ఈస్ ద 8259. నెక్స్ట్ 8255 ద ప్రోగ్రామబుల్ పెరిఫెరల్, దట్ ఈస్ ద జనరల్ పర్పస్. నెక్స్ట్ DMA అంటే ప్రాసెస్ ని బైపాస్ చేసి డేటా ట్రాన్స్ఫర్ అనేది ఇన్పుట్ బోత్ ఎక్స్టర్నల్ డివైస్ మధ్యలో అవుతాయి, దట్ ఈస్ ద DMA కంట్రోల్. ద లాస్ట్ వన్ 8259 ఇది సిలబస్ లో లేదు, బట్ యు కెన్ రైట్ డౌన్. 8279 the programmable keyboard controller. 8279 programmable keyboard or display controller. Programmable keyboard and or display controller. Next, put heading DMA controller. Direct memory access. Direct memory access controller 8257. Okay, the features of 8257 is 8257 నే ఇంకో నేమ్ అంటే ఇంకో ప్రాసెసర్ వచ్చేసి ఇంకో DMA కంట్రోల్ 8237. మీరు బ్రాకెట్ లో కూడా రాసుకోవచ్చు. DMA కంట్రోల్ 8257 ఇన్ బ్రాకెట్ 8237. both are same purpose. And this DMA 8257 is having the four channels. Each channel can connect the one device. ఇక్కడ 4 channels అంటే DMA controller is connecting to the 8086 microprocessor. Okay, next, using these 4 channels you can connect the 2 devices to this DMA. ఈ 2 device DMA connect చేస్తే without involvement of 8086 microprocessor, these 2 devices can exchange the information, transfer the information between the one device to other device without involvement of processor. అంటే ఏంటి ఇక్కడ? What is the advantage of this DMA? We are saving the processor time because processor is not involving exchanging the data between 2 external devices. And this 4 IO device can be interfaced to DMA. It is designed by who is the invented this? Intel. Like 8086 also Intel and 8051 also Intel. The each channel have the 16-bit address and 14-bit counter lines. It provides chip priority resolver that resolves the priority of channels in fixed or rotating mode. Anyone can justify the last statement? It provides chip priority resolver that resolves priority of channels in fixed or rotating mode. How many devices we are connecting at a time? 4 channels are there. I taken the example 2. The 4 channels are there. For the each channel, one external device. So we can connect the 4 external devices. ఆ 4 external device connect చేసినప్పుడు what is the priority? అంటే దేనికి ఫస్ట్ సర్వ్ చేయాలి, దేనికి నెక్స్ట్ అలాట్ చేయాలి, what is the third one, what is the fourth one, like that. Okay, so for that one priority resolver is there. That priority resolver will gives the priority among that 4 devices. This is the 8257. 8257 pin diagram. It is also having 40 pins, the 1 to 20 and 21 to 40. IO read, IO write. IO read means input output read, input output write, memory read, memory write. What is the IO read and what is the memory read? That can read the address. Read the address of the external memory device. Next, IO read means input output device. And this one is the no connection. Ready. If the ready is the enable, this 8257 is the ready to serve. Next, the hold HLDA. The HLDA and HOLD. Where is the HOLD? Yeah. HLDA and HRQ. The same pins are having in 8086 also. You can see the pin diagram of 8086 microprocessor. The 8086 also having the hold and hold acknowledgement. Hold and hold acknowledgement. Here, the same. The any processor is requesting through the hold pin. That is a request. Next, hold acknowledgement. If the process bus is free or not, through the acknowledge to the external devices using hold acknowledgement. Next, address to address enable, chip select, and clock generation, reset. The all external devices are having the pin like reset and as well as CS. The CS is the chip select pin and reset to reset this device to reach the initial position of this 8257 DMA controller. You can apply the reset pin. Next, data acknowledgement, and data request 2, data request 1, and data request 0, ground pin, and VCC we are applying to the 31 pin. Next, address pins A0, A1, A2, 3, A4, A5, A6, A7 are address pins, and data pins are DB0 to DB7. The 8-bit data bus and 8-bit address bus. Using this address and data buses, the data can be transferred between the two external devices without involving. But the connection establishment is done by the only processor. The pin description same, D0 to D7 for the data exchange, the data transferring bus, and A8 to A15, the address. Next. In the slave mode, bidirectional. In the master mode, unidirectional. Anyone can, what is the slave mode and what is the master mode? Slave and master. What is slave and what is master? Master ante task assign. Correct. ఇప్పుడు 2 డివైస్ కనెక్ట్ ఉన్నాయి అనుకోండి ప్యారలల్ గా సిరీస్ లో ఒక డివైస్ నుంచి ఇంకో డివైస్. సో ఇందులో ఏదైతే మైక్రో ప్రాసెసర్ కనెక్షన్ ఉందో దట్ విల్ కంట్రోలింగ్ ది another device. So that is called the master, and the last device is called slave. So here also, here in the slave mode, that means if the DMA controller is the slave working under slave mode, ఎప్పుడు slave mode గా వర్క్ చేస్తుంది ఇది? Once the connection is established and before when 8257 is work function as a slave and when it acts as a master. మాస్టర్ గా ఎప్పుడు వర్క్ అవుతుంది, స్లేవ్ గా ఎప్పుడు వర్క్ అవుతుంది? వీఆర్ కనెక్టెడ్ ద 8257 టు ప్రాసెసర్ and 4 more other devices to 8257 micro DMA controller. Okay, when the processor this 8257 is acting as a slave and when it is acting as a master. In initial position, Before establishing the connection between these two external devices, the slave can be operated by the microprocessor. In that case, the 8257 is act as a slave mode. ఎందుకంటే ప్రాసెసర్ 8257 కంట్రోల్ చేస్తుంది. సో ద 8257 is slave mode. Once slave mode is over, ఎప్పుడు ఓవర్ అవుతుంది? Whenever the connection is established between the two external devices. అంటే అప్పుడు ఏది కంట్రోల్ చేస్తుంది ఆ ఎక్స్టర్నల్ డివైజెస్ ని? This 8257. So in that case, in the second phase of DMA controller, that acts as a master. ఆ మాస్టర్ ఉన్నప్పుడు 8257 8086 ఇన్వాల్వ్మెంట్ ఉండదు. 8086 ఇన్వాల్వ్మెంట్ లేనప్పుడు 8257 acts as a master. 8086 ఇన్వాల్వ్మెంట్ ఉంటే the 8257 is acts as a slave mode. నెక్స్ట్ రీడ్ అండ్ రైట్ పిన్స్. మీకు దీన్ని అడిగితే ఓన్లీ 4 మార్క్స్ 5 మార్క్స్ అడిగితే what is the purpose of the DMA controller, or what are the features of DMA controller? Okay, so in that case you can explain without involvement of the, after establishing the connection between the two external processors, the 8086 processor is not involving in the data transfer between the external devices. Only the 8257 acts as a master for the two external devices, and the data transfer can be happen between the two devices without involvement of processor. Okay, that is the main purpose of this DMA. Then they will ask the pin diagram. Okay, so here IO read, and you can see the IO write, clock generation, this DMA controller is having total 1 2 3 4 5 blocks along with 4 different channels. The 4 different channels, that is the DRQ0, the each channel is having one data request pin. These are the 4 channels: channel 0, channel 1, channel 2, channel 3. The 4 channels, the each channel is having the address 16-bit address pin and 14-bit counter. You can see the all this 16-bit address bus and 14-bit counter bus, and 14-bit counter, not bus, 14-bit counter, and 16-bit, 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 16-bit address. So the data can be transferred in the 16-bit address, and the each channel is having data request and data acknowledgement. Data request and data acknowledgement. Then here the data bus buffer, the data bus buffer is connecting to the 8086 microprocessor to send the data or to control this device. To control the 8257, the microprocessor is sending the data from the 8086 to DMA controller using D0 to D7, and these are the control pins. Okay, read write logic and control logic and mode set register mode. Okay, these are the 4 channels. For the 4 channels, you can connect the 4 different devices and priority resolver. The priority, the which channel can serve first, depending here the different priorities. There is a rotating mode ante bubble sort gurtunda. Bubble sort eta work avutundi. మీ క్యూస్ లో వస్తాయి. ఏది కంప్యూటర్ నెట్వర్క్ సబ్జెక్ట్ ఉందా? కంప్యూటర్ నెట్వర్క్స్ దాంట్లో ప్రయారిటీ లెవెల్స్ ఉంటాయి. బబుల్ సార్ట్ సార్టింగ్ కాదు, ఐఎమ్ నాట్ గెటింగ్ రైట్ నౌ. అండ్ రౌండ్ రాబిన్ విన్నర్ అవార్డు. వాట్ ఈస్ ద ఫంక్షన్ ఆఫ్ ద రౌండ్ రాబిన్? ఆ రౌండ్ రాబిన్ లో ఒక డివైస్ కి 5 minutes ఇస్తుంది. Next 5 minutes completion tarata next device. So here like that, this priority resolver also giving the priority, that is a fixed priority or rotating priority. So in that rotating priority, they are using the round robin fashion. Round robin. ఆ డిలే ఎంత అనొచ్చు 5 minutes ఉండొచ్చు 5 seconds ఉండొచ్చు 10 minutes ఎంత ఉండొచ్చు. Okay, so that is the rotating mode. And 4 different channels, the channel 0, channel 1, channel 2, channel 3. Next, all this, the 5 blocks, this. How many total? 5 main blocks. One is the data bus buffer, read write logic, control logic, priority resolver, and DMA channels. Data bus buffer, the read write logic, control logic, priority 1, 2, 3, 4, and channels. 4 channels. So the 4, the 8257 is categorized into 5 blocks. One is the data bus buffer and read write logic. Next, control logic. This is a read control gadu. Read write logic. The read write logic, control logic, the priority resolver, and DMA channels. The 4 channels: channel 0, channel 1, channel 2. The each DMA channel is having the data request pins and the data acknowledgement pin. Data bus buffer, it contains the 8-bit bidirectional bus. 8 is, that is the D0 to D7. You can remember this structure now. The data bus buffer D0 to D7 and read write logic is having IO read, IO write, and A0, A1, A2, A3 chip select. Then the control logic is the A4, A5, A6, A7, ready, hold request, hold acknowledgement, memory read, memory write, address enable, address true, and TC mark. Then data request 0, data acknowledgement 0, DRQ1, DACQ1, and here the 4 channels request access. Now it contains the 8-bit data bus buffer is having 8-bit channel, that is the D0 to D7. Next, in slave mode, whenever the processor is controlling the 8257, that is the 8257 acts as a slave. So under slave mode, it transfers the data between the microprocessor and internal data bus. Right? Slave mode ఎప్పుడు మైక్రోప్రాసెసర్ దీన్ని కంట్రోల్ చేస్తే ఇదేని 8257. So that is called the slave mode. In the slave mode, the data transfer between the processor and data bus buffer, that is a D0 to D7. Under master mode, the output A8 to A15 bits of memory address and data lines of unidirect. Master mode ante it is getting the external devices. Read write control logic, it controls the all internal read and write operations. And slave mode, it accepts the address bits and control signals from microprocessor. ఒకటే గుర్తు, స్లేవ్ అంటే వేరే వాడు ఆపరేట్ చేస్తుంటాడు, మాస్టర్ అంటే మనమే ఫుల్ రైట్ అంతే. మాస్టర్ ఓకే. In master mode, it generates the address bits. But in the slave mode, the control bits from microprocessor. Master mode, it can generate the control signals. And the control second block, control logic block. It contains control logic pins, mode set registers, and status register. Next, modes, it contains control logic. The second block contains, that is a control logic block. It contains control logic and mode set register and status register. Mode set similar to control word register in 8255. Control logic, master mode, it controls the sequence of DMA operation during all DMA cycles. DMA cycles and data transfer between the external devices. The each transfer can under the clock pulse. మీకు డిజిటల్లో ఏ టాస్క్ కంప్లీట్ కావాలన్నా క్లాక్ సైకిల్ కంపల్సరీ ఉంటుంది, బట్ అది చదవట్లేదు, బట్ క్లాక్ సైకిల్ ఈస్ కంపల్సరీ. నెక్స్ట్ ఇట్ జనరేట్స్ అడ్రస్ అండ్ డేటా కంట్రోల్ సిగ్నల్స్ and it increments 16-bit address and decrement 14-bit counter registers. 16-bit address అంటే ఫస్ట్ 00లో డేటా ఉంది, ఆ డేటా ట్రాన్స్ఫర్ అయింది, నెక్స్ట్ ఏం కావాలి, నెక్స్ట్ 001 కావాలి. సో దట్ ఈస్ ఇంక్రిమెంటింగ్ ద అడ్రస్, ఇంక్రిమెంటింగ్ ది 16-bit అడ్రస్ and decrementing the 14-bit counter registers. Next, it activates hold request and DMA channel request. Slave mode is disabled. ఏంటిది స్లేవ్ మోడ్ ఇస్ డిసేబుల్డ్? అది మాస్టర్గా ఉన్నప్పుడు స్లేవ్ మోడ్ ఎలా ఉంటుంది, డిసేబుల్ అంతే. సో వన్స్ ద ప్రాసెస్ ఇస్ గివెన్ authority to 8257, that 8257 acts as a master. So obviously the slave mode will be disabled. And mode set registers, it is write only registers. It is used to set the operating modes, different operating modes of 8257. And this register programmed after initialization of DMA channel. This can be programmed after initialization of DMA channels. And here the mode set register is D0 to D7. This is the pin configuration. Now the each one AL, TCS, EW, RP, enable 3, enable 2 and enable 0. You can see AL equal to auto load mode, rotating mode. AL stands for auto load, and TCS transfer stop after TC, the timer counter, 14-bit counter. So then start after TC, EW extended write, extended normal mode, rotating priority, fixed priority. Rotating priority అంటే round robin fashion, round robin method. Fixed అంటే fixed, దాని టాస్క్ కంప్లీట్ అయిన తర్వాత నెక్స్ట్ ఛాన్స్ గివెన్ టు ద నెక్స్ట్ ఛానల్ డివైస్. The out of 4 channels, if you are giving the fixed priority to the any one device, only that can access the address and data buses, not in the rotating. But if you are keeping this RP is equal to 1, that is a rotating priority. The priority levels can be rotating among that 4 different channels. Next, enable DMA channel 3, enable, disable, enable this enable channels, enable channel 3, enable 2 ante enable channel 0, channel 1, channel 2, channel 3. If you want to enable the channel 1, then you can keep it here, EN0 is equal to 1. And if you want to disable, you can make it here 0. 1 means enable, 0 means disable, up to 4 channels. The channel 0, channel 1, channel 2, channel 3. And here, this is the rotate priority resolver. How we are giving the priority. RP is equal to 1, rotating priority. RP is equal to 0, that is a fixed priority. Fixed ante, ఇంకా వేరే దానికి ఛాన్స్ ఉండదు, మొత్తం that will take. Whole time. And the extended write operation and auto load and auto reload. That is, what is the register name? Mode set register. Next, status register. It is only read only register. Status అంటే which status? 8257 status. అది ఏ మోడ్ లో ఉంది? Writing operation or reading operation. This status register read by the processor. అంటే ఇందులో ఉన్న డేటాని ప్రాసెసర్ రీడ్ చేసి the processor will decide the 8257 is in which status. TC0, 0, TC1, TC2, TC3. The channel 0, channel 1, channel 2, channel 3. ఇందులో ఏది 1 ఉంటే ఆ ఛానల్ యాక్టివ్ లో ఉంది. దాని మీనింగ్ అంటే ప్రాసెసర్, how the processor is understanding the which channel is serving for the which external devices depending on this status register. For example, TC0 is equal 0. ఈ ప్లేస్ లో 1 ఉంటే the channel 0 is active. The device connected to the channel 0 is active. Otherwise, no. Okay. Same story for this. TC2 is equal to 1 means the TC activated for channel 2. Now, how we are connecting the 8257? Okay, see here. What happened? Okay. See the 8086 and the same bus multiplexer, two buses, not two buses. The D0 to D7 of 8257 is connected to 8086. దీని స్టేటస్ రీడ్ చేయాలంటే the bus is direction like this. If the control, if you want, if the 8086 is controlling the 8257, this direction. Okay. So now here the four different channels: channel 0, channel 1, channel 2, channel 3. Now actually this is the memory device, and this assume this is the memory device and this one is the IO device. For the each data transfer between the memory device and IO device, always this data is sending to the 8086 via 8257, then 8086 to IO device. That is a very complicated for the 8086 microprocessor. So that's why the DMA is bypassing this 8086 microprocessor by establishing the connection between this IO memory device and IO device. Once the connection is established, both will be exchanging the information. Now the priority resolver, if these two are involving the action, if you are giving the fixed priority. So if you are giving the rotating priority, the all will share the address and data buses of 8257 DMA controller. Simply, ఈ DMA controller purpose ఏంటంటే to improve the performance of 8086 microprocessor. To improve the performance of, why it is improving? Because 8086 is not involving the external data exchange. Okay. If they are asking the draw the interfacing diagram, simply you can draw the 8086 and D0 to data lines. D0 to D7 you can connect here. And 8257 D0 to D7 you can connect. Then the four channels. The four channels you can connect to the four external devices. Okay. Next. Time 3:50. Bus ఎన్ని గంటలకి? 4. Okay. Now, I will stop now. Now, how to connect this LED device to this the external device? This external device, how to connect to the 8086 microprocessor? The same application we did with the 8051 microcontroller, right? ఇది ఎలా చేయాలి? How to connect LED to 8086 microprocessor? LED ni glow చేయాలి. First glow చేయాలంటే we need to finish the hardware connections. So how to connect this LED to 8086 microprocessor? ఎలా? How to connect 8086 with LED? Pins. But 8086 doesn't have the any input and output pins. Interfacing kavali. Which so I given the many interfacing devices. One is 8257 DMA controller, 8255, 8257, 8251, 8279. Among this, the which one is suitable? 8255 is the PPI, the programmable peripheral interface. That is the general purpose PPI. The DMA అంటే only memory transfer మాత్రమే యూజ్ అవుతుంది. Memory transfer లేకుంటే we can't use the DMA controller 8257. But 8255 is the general purpose PPI, the programmable interfacing device. So now the microprocessor is connecting to the 8255. For that 8255 is the IO lines. ఎన్ని ఉన్నాయి? 24 IO lines ఉన్నాయి. ఆ 24 IO lines లో ఎనీ వన్ లైన్ యూ కెన్ యూజ్. ఇప్పుడు గ్లో చేయాలి బల్బుని. ఎలా గ్లో చేయాలి? ఎలా గ్లో చేయాలి? ఎలా how to write the program? Simple connections. Listen everyone. Microprocessor data bus to, what is the data bus size? 8-bit only. Okay. Now, so 8-bit data bus to and D0 to D7 of 8086 to D0 to D7 of 8255. Next 8255 other side ఏమున్నాయి? IO lines ఉన్నాయి. యూజింగ్ పోర్ట్ ఏ, పోర్ట్ బి, పోర్ట్ సి. అందులో ఏ పోర్ట్ వాడదాం అనుకున్నారు? పోర్ట్ ఏ. ఫర్ ఎగ్జాంపుల్ అజ్యూమ్ ద పోర్ట్ ఏ. సో నౌ దట్ పోర్ట్ ఏలో ఎన్ని పిన్స్ కావాలి ఎల్ఈడి కనెక్ట్ చేయడానికి? ఓన్లీ టూ పిన్స్. ప్లస్ మైనస్ రెండో పోర్ట్కి ఇచ్చేసేయండి. ఓకే. సో ద 2 పిన్స్. ఆ పోర్ట్ ఏలో PA0, PA1 ఉన్నాయి కదా. ఆ PA0కి ప్లస్ వైర్ ఇవ్వండి, PA1కి మైనస్ వైర్ ఇవ్వండి ఆఫ్ ఎల్ఈడి డివైస్. నౌ హౌ టు గ్లో ద డివైస్? ఎల్ఈడి గ్లో చేయాలి. ఏం చేయాలి? వాట్ ఈస్ ద సైజ్ ఆఫ్ ద PA7? 8-bit. P అంటే పోర్ట్ ఏ అమ్మా. పోర్ట్ ఏ ఎన్ని పిన్స్ ఉన్నాయి? 8. ఆ 8 పిన్స్ లో లోయర్ LSBకి PA0కి ప్లస్ వైర్ ఇచ్చాము, PA1కి మైనస్ వైర్ ఇచ్చాం ఆఫ్ ఎల్ఈడి. ఓకే. ఇప్పుడు గ్లో కావాలంటే మనం ఎట్లా అప్లై చేయాలి? PA0కి 1 ఇవ్వాలి, PA1కి 0 ఇవ్వాలి. అదర్ పిన్స్ వీఆర్ నాట్ యూజింగ్. సో ఇప్పుడు ప్రాసెసర్ నుంచి డేటా ఏం పంపించాలి? ప్రోగ్రామింగ్ ఎలా రాయాలి? ఓకే. సో ఫర్ దట్ you can move the AL is equal to 01 hexadecimal number. What is the 01? 0000 1 కి 0001 మనకి రిక్వైర్డ్ డేటా వచ్చిందా? సో మూవ్ AL, 01 out. Next line, out is the output instruction, one of the instruction in 8086. చూడండి మీరు లిస్ట్ అవుట్ చేయండి డేటా ట్రాన్స్ఫర్ లో. అవుట్, OUT, అవుట్ AL, అవుట్ పోర్ట్ ఏ PA, పోర్ట్ ఏ AL. ఏలో ఏముంది? 01 ఉంది, హెక్సాడెసిమల్ నంబర్. నెక్స్ట్ అవుట్ పోర్ట్ ఏ AL అంటే ఏలో ఉన్న కంటెంట్ పోర్ట్ ఏలోకి వెళ్తుంది. బట్ పోర్ట్ ఏకి ఏం కనెక్షన్ ఉంది? ఎల్ఈడి కనెక్షన్ ఉంది. సో ఆటోమేటికలీ ద ఎల్ఈడి విల్ గ్లో. రైట్. మూవ్ AL ఈజ్ ఈక్వల్ టు డైరెక్ట్ 01 ని డైరెక్ట్ పోర్ట్ ఏకి ఇవ్వలేం. త్రో ఓన్లీ యూజింగ్ ద ప్రాసెసర్ రిజిస్టర్ AL ఆర్ అక్యుములేటర్ రిజిస్టర్, కంప్లీట్ అక్యుములేటర్ 16-bit. మనకు డేటా ఉంటే 8-bit కాబట్టి ఇక్కడ. సో మూవ్ AL, 01 అవుట్ పోర్ట్ ఏ AL. ఆటోమేటికలీ అవర్ డివైస్ విల్ గ్లో. మీరు దాన్ని ఆఫ్ చేయాలంటే ఏం చేయాలి? నెక్స్ట్ మూవ్ AL సమ్ డిలే ఇవ్వండి. నెక్స్ట్ సేమ్ సిమిలర్ టు 8051 మైక్రో కంట్రోలర్. ప్రొవైడ్ ద డిలే. ఆఫ్టర్ ద డిలే అగైన్ move AL, 00 and out port A, AL. Again delay. Again you can repeat the same program continuously. So your LED will glow automatically. చూడండి ఇక్కడ ఎల్ఈడి దేని కనెక్షన్ చేశాం? పోర్ట్ పిన్, ఎనీ పోర్ట్. ఆ పోర్ట్స్ ఎక్కడ కనెక్షన్ ఉంటాయి? మళ్ళీ 8086 మైక్రో ప్రాసెసర్ కి. ఇది 7 సెగ్మెంట్ డిస్ప్లే. సింపుల్. ఇది ఇవి LEDs. Or you can assume the one LED to port A and port A data pins to ఇక్కడ ఉంటుంది మైక్రోప్రాసెసర్ డేటా పిన్స్. ఓకే. మీకు నేను రాసిన బ్లాక్ డయాగ్రమ్ గ్రీన్ కలర్ లో రాసిన, బ్లూ కలర్ రాసిన బ్లాక్ డయాగ్రమ్ గుర్తుంటే యూ కెన్ కనెక్ట్ ద ఎనీ ఇంటర్ఫేసింగ్ సర్క్యూట్. ఓకే. యూ కెన్ రిమెంబర్ దట్ డయాగ్రామ్స్. ఓకే. థ్యాంక్ యూ. If you are having any doubt, you can ask me according to today's class or previous classes. Anyone? Okay, thank you. If you want to ask the any doubt personally, you can come here. Others, you can contact your coordinators.